All right, let's try part B, and then I'll have you try one out. So, all right, so part B, the first thing we're going to do is we're going to evaluate the function at the endpoint. So we're going to find f of 0, which is always pretty easy to do usually if you have a polynomial type. And so we're just plugging in 0 for x, and usually when you plug in 0, things go away, right? And so that makes, you don't have to necessarily show this work, especially when you plug in 0, but 0 squared is 0, right? So that turns into 0, and then 0 to the 2/3 power is 0, and 3 times 0 is 0, so that all turns into 0. So f of 0 is actually 0. All right, so that was nice and friendly. F of 2 is going to involve a little more work. So 2 squared is 4, right? And then 2 to the 2/3 power, so that's going to be the cube root of 4, right? The cube root of 2 squared is 4. So this is, just to kind of convert that to radical form, right? That's what it would be. The denominator becomes the index, and the numerator becomes the inside exponent, or the exponent on the right. And so, yeah, so the cube root of 2 squared is the cube root of 4, and then we have that 3 in front. Okay, so this is an expression that can't be simplified anymore, but we can approximate it, right? Just so we can kind of see what the value is, so we can compare it, right? Like, as it stands, even comparing to 0, you know, this seems to be more than 4, and so 4 minus a value that's greater than 4 would be a negative, it seems like. But yeah, let's plug it into our calculator and just find out. So so plug this whole expression in your calculator and see what you get. All right, and it comes out to approximately negative 7.622, right? And then dot, dot, dot. So this is an irrational number, so the decimal goes on forever without a pattern. You can kind of get a sense of that to some extent. All right, but anytime you have a radical that doesn't simplify, it's going to be an irrational number. All right, so we found those. Now let's find the critical point. So I'm going to find the derivative and then set it equal to 0. So the derivative would be 2x minus, and then here, so the derivative of x squared is 2x. The derivative of negative 3x to the 2/3 power. What I'm going to do is I'm going to multiply by 2/3. So 2/3 times 3 is 2x to the, and then I'll take away 1 from 2/3, or I'll subtract 1, and so it'll be negative 1/3, right? Okay, and so I can rewrite this as 2x minus 2 over the cube root of x. All right, and if I want to set that equal to 0, I could do this a few different ways, but yeah, let's set this equal to 0. And so I'm going to say 0 equals 2x minus 2 over cube root of x. And so then I'll add 2 over cube root of x to both sides, so I'll end up with 2 cube root x equals 2x. And then what I'm going to do is cross multiply. And so what I'll end up with is 2x cube root x on one side, and then since we have an invisible 1 down there, 2 times 1 is 2, so we have that. Okay, then we can divide both sides by 2. So we actually end up with 1 equals x cube root, or x times the cube root of x. All right, And another way to write that is x to the, because remember here we have x to the first times x to the, this is 1 over 3. And remember, when we multiply bases, we add the exponents, right? When we have like bases here, we can add the exponents when we multiply them. And so when we multiply the bases, we add the exponents. And so 1 plus a third is 4/3. Okay, so what we can do is we can take the, well, let's do it this way. We can raise both sides to the 3/4 power, right? And that will cancel out this, right? And so we'll end up with x to the first power equals 1 to the 3/4 power, and 1 to any power is 1, right? So x to the first is just 1, or x to the first is the same as x, so really x equals 1. So that's our critical point, okay? And there were a few different ways we could have approached that problem and solved for x, but yeah, that's the one that just kind of came to me. All right, and so now we want to figure out what is f of 1, right? So now that I know the critical point, now I want to find, okay, what is f of 1? What if I plug 1 into the original function? So that would be 1 squared minus 3 times 1 to the 2/3 power, right? And we just talked about 1 to any power is 1, so this will turn into 1, and this will turn into 1. So it's going to be 1 minus 3 times 1, which is 3, right? And 1 minus 3 is -2. All right, so now we compare the values. So what's the largest of these values, right? We're comparing 0 with -7.6 approximately with -2. And I messed up on this. This should be -0.7622. So that should go right here. -0.7622. You probably already figured that out. All right, and okay. But anyway, if we're comparing those three values, the largest of those values is 0, right? That's the only one that's not negative. So the largest of those values is 0, so that'll be our maximum. Okay. So we have a max at 0 of 0, right? So max at x equals 0, and that maximum value is 0. Okay, and then let's find the minimum of those values, right? Of these three well, we don't have to worry about 0 anymore, but of these two values, which is the smallest, and the answer would be -2, right? And so we have a minimum, an absolute minimum at x equals 1, right? And then the minimum value is -2. All right. So those are our max and our min. So let's look at the graph and see what that looks like. Okay, so we have this function, and we found on this interval from 0 to 2, we found the endpoints. We found the value or the output at the endpoints, which was 0 and -0.762 approximately, right? And then we found the critical point, which was at 1, and that value turned out to be -2, right? And so our maximum value, like we talked about, was at 0, and the output and the maximum value was 0. And then we found the minimum value, which was which happened at 1, and that value, the minimum value, was -2. All right, so that's how you find critical points. So find the value at the endpoints, and find a critical point, and then find the value at that point, and then you compare the values.